Hello viewers, tutorial 4 question 2, and we have a simultaneous equations problem to solve. We have y equals x squared plus 4 and y equals 3x plus 2. So we notice that we've got an x squared in the system of equations, and that tells us that we can't really use elimination. So we're forced to go with substitution, or in this case, looking at the two equations we've got, they both have the same left-hand side, namely y, which means they must have the same right-hand side. So we can set the two right-hand sides equal to each other. So x squared plus 4 equals 3x plus 2. And if we move the 3x to the other side, so that becomes x squared minus 3x plus, this will be a quadratic equation, it's got an x squared in it, so we want to move everything to the left-hand side. So if we move this 2 over, we get 4 minus 2, giving us 2 equals 0. So this we want to factorise. We're looking for two numbers that add to negative 3, but multiply to 2. Clearly those two numbers are minus 2 and minus 1. So when the first bracket is 0, when x minus 2 equals 0, that tells us that x equals 2. And when the second bracket is 0, x minus 1 equals 0 means x equals 1 are our two answers for x. But we need to keep going because we need to find y as well. So we'll substitute our two x values separately into one of the original equations. I'll choose the first one. We'll go with x squared plus 4. So when x equals 2, y is going to be, x is 2, so that will be 2 squared plus 4. 2 squared is 4, so that's going to be 4 plus 4, which is 8. And we'll check that that fits the other equation. Y equals 3x, well that's 3 times 2 because x is 2, which is 6, plus 2 gives us 8. Okay, good. Now what about the other solution, which is when x equals 1, y equals 1 squared plus 4 gives us 5. And let's check equation 2. 3x is 3 times 1, which is 3, plus 2 is 5. Okay, so our solutions are xy equals 2 and 8, and when x is 1, y is 5. Okay, so that is question A. Now we have question B, which is the system of equations y equals 2x squared minus 8 and y equals 5x minus 10. So again, we can use the same argument. Both equations have the same left-hand side, which is y, which means that we can set the right-hand sides equal to each other. If the left-hand sides are the same, then the right-hand sides must be the same. So that gives rise to 2x squared minus 8 equals 5x minus 10, which will be another quadratic equation. We want to move everything to one side, so this will give us, if we move the 5x to the other side, we get 2x squared minus 5x. Let's move the minus 10 to the other side, so minus 8 plus 10 is plus 2 equals 0. So that's a quadratic equation. This one does factorise. We could do our systematic thing if we wanted to. So what's our A? So A equals 2. So we've got A equals 2, B equals negative 5, and C equals 2. AC is 4, B equals negative 5. Okay, so we're looking for two numbers that add to negative 5, but they multiply to 4. Clearly the two numbers that we want are negative 4 and negative 1, because negative 4 times negative 1 is positive 4, and negative 4 plus negative 1 gives us negative 5. So we can write this as 2x squared minus 4x minus x plus 2 equals 0. And now we can pairwise factorise. The first pair, 2x squared minus 4x, has a common factor of 2x times x minus 2 minus taking out a common factor of negative 1 to keep that third sign the same, gives us an x minus 2 equals 0. So one bracket is clearly x minus 2, and the other one is going to be 2x minus 1. Okay, so we've got two solutions. So from this second bracket, x minus 2 equals 0, tells us that x equals 2, and from the first bracket, 2x minus 1 equals 0. If we move the 1 to the other side on that equation, we get 2x equals 1. Divide that by 2, we get x equals 1/2. So when x equals 2, let's start with 2. Y equals, which equation should we choose for substitution? Y equals, we'll go with the second one here, 5 times 2 minus 10, which gives us 0, because 5 times 2 is 10, minus 10 gives us 0. And let's check that that fits the other equation. That's going to be 2x squared minus 8. Well, x squared is going to be 4 when x is 2. 2 times x squared will therefore be 8. 8 minus 8 gives us 0. Good. Okay, so when x equals 1/2, y equals 5 times 1/2 minus 10. So 5 times 1/2 is 5 upon 2 minus 10. 10 is 20 upon 2, so we've got 5 upon 2 minus 20 upon 2, which is negative 15 over 2. Okay, let's check that that fits the first equation, which was 2x squared minus 8. So that will be x squared is 1/2 squared, which is 1/4. 2x squared is therefore 2 times 1/4, which is 1/2. So we've got 1/2 minus 8, which is 1/2 minus 8 is 16 over 2. So 1/2 1 over 2 minus 16 over 2 equals negative 15 over 2. Okay, good. So our solutions are, first one was 2, 0, and the second solution was 1/2, negative 15 over 2. So we've got two solutions there, and now we have question C, which is the following system. So we've got 5x plus y equals 18, and 4x squared minus 7y equals 15. Here we cannot make the argument that both sides of the equation have the same left-hand side. We have to use substitution proper. So we have a first equation and we have a second equation. Using substitution, what should we do? Solve one of the equations for either x or for y. Easiest thing to do there would be to solve the first equation for y, which is moving the 5x to the other side. So from equation 1 we get y is 18 minus 5x, and we'll substitute into equation 2. Okay, so we get 4x squared minus 7 times y, but y we've just found to be 18 minus 5x equals 15. So we've got 4x squared, let's multiply that 7 into the bracket, so minus 7 times 18 I believe is minus 126. Minus 7 times minus 5 is plus 35x. Then we've got the minus 15, which is going to give us what we see there. And we can combine terms here, so we've got a minus 126 minus 15, which will give us minus 141 equals 0. Okay, so I'm not even going to try factorising this one. I'm just going to go straight to the quadratic formula. So A is in this case 4, B is 35, and C is negative 141. The quadratic formula is negative b plus minus square root of b squared minus 4ac divided by 2a. Putting in the numbers there, we get negative 35 plus minus square root of 35 squared minus 4 times a, which is 4 times c is minus 141. That's divided by 2 times a, which is 2 times 4, which is 8. And if we calculate that, we get two solutions. We get x equals 3 is one solution, and the other solution is x equals, turns out to be negative 47 over 4. So we've got two solutions, x equals 3 and y equals negative 47 over 4. We need to find out what y is, so we'll substitute those into our rearrangement for y, which was 18 minus 5x. So when x equals 3, y equals 18 minus 5 times 3. 5 times 3 is 15, so we've got 18 minus 15, which is 3. So when x is 3, y is 3. Let's check that this comes from equation 1, so let's check it fits equation 2. X is 3, so x squared is 3 squared is 9, times 4 gives us 36, so 4x squared is 36. 7 times y, we just found y is 3, so 7 times y is 21, 36 minus 21 is 15. Okay, good. What about when x equals negative 47 over 4? So when x equals negative 47 over 4, we get y equals 18 minus 5 times minus 47 over 4, which is, that turns out to be 307 over 4. Okay, so another way we could check this by putting into our calculator. 4 times x was negative 47 over 4 squared minus 7 times 307 over 4 equals, put that in your calculator, that does turn out to be 15, so that works. Okay, so our solutions are x, y equals, first solution was 3, 3, second solution was negative 47 over 4 and 307 over 4. Okay, thanks for watching, over and out.